Europe is living through its fifth major heat wave in roughly 12 weeks, and meteorologists tracking it closely have noticed something genuinely different this time around. It isn't just repeating the same pattern as the four punishing events that came before it. The jet stream itself has shifted into a new, distinct position, and that single change is reshaping which countries bake, which ones flood, and why researchers now believe the underlying cause traces all the way back to melting ice in distant Greenland. Let's quickly establish the scale of what Europe has already endured this year, because the fifth event only makes sense in the context of everything preceding it. The first heat wave struck in late May, a historic, record-shattering event that pushed temperatures 10 to 15 degrees Celsius above normal and broke all-time records for the highest May and springtime temperatures ever recorded across Spain, the United Kingdom, Germany, France, and Ireland. Mora, Portugal, hit 40.3 degrees Celsius on May 27th, an extraordinary reading for that early in the season. Successive waves through June and July kept hammering different regions, with France confirming more than 2,000 heat-related deaths from the June event alone, and a preprint analysis estimating the continent-wide toll for a single week of that same stretch exceeded 20,000 people. By early August, running estimated death tolls compiled from early attribution and excess mortality analysis across the continent had already climbed well past 9,900, a figure researchers expect will continue rising as postseason data gets fully analyzed in the months ahead. Now, heading into mid-August, a fifth heat dome has expanded across the continent, and forecasters are describing its behavior in genuinely distinct terms compared to the waves before it. Temperatures are running 12 to 16 degrees Celsius above the long-term average for mid-August across Spain, France, the Benelux countries, and England. But rather than settling into roughly the same footprint as the previous four events, this heat dome is doing something meaningfully different. It's elongating and pushing considerably farther north and east than its predecessors. Here's where the jet stream position becomes the actual explanation, rather than just a technical footnote buried in a forecast discussion. Meteorologists tracking this event have identified a deep wave forming over the North Atlantic, a configuration that allows a strong warm air plume to push unusually far north across Western Europe and into Northwestern Europe specifically, rather than remaining locked over the traditional Iberian and French heat dome zone that dominated the earlier waves this summer. As that upper-level wave over the Atlantic weakens and shifts into Western Europe, the heat dome itself becomes considerably more elongated, stretching over Central Europe and intensifying conditions specifically for Germany, the Alpine region, Italy, and the Northern Balkans, while simultaneously pushing much higher temperatures into Denmark, southern Scandinavia, and the Baltic region, areas that largely escaped the worst of the first four heat waves entirely. That northward and eastward expansion matters enormously, because it means this fifth event is exposing populations and infrastructure that hadn't yet faced this summer's most extreme conditions. Scandinavia and the Baltic states, regions with historically among the mildest summer climates on the continent, and correspondingly among the least air conditioning infrastructure anywhere in Europe, are now being pulled directly into the path of extreme heat that previously stayed, concentrated further south and west. Separate medium-range forecasts have also flagged the heat wave's continued eastward expansion into the western Black Sea region as the pattern progresses through the following week, extending this event's reach even further than the initial forecasts suggested, and underscoring just how differently this fifth wave is behaving compared to the more geographically contained events that preceded it earlier in the summer. If you're finding this kind of grounded, evidence-based breakdown genuinely valuable, go ahead and hit that like button. It makes a real difference, helping this channel reach more people who want real context behind these headlines instead of vague alarm with nothing to back it up. So what's actually driving the jet stream into this different configuration, rather than simply repeating the same omega block pattern that dominated June and July? Researchers examining Europe's accelerating warming trend have pointed to a genuinely fascinating and somewhat counterintuitive physical mechanism: meltwater pouring off the Greenland ice sheet. As that fresh, cold meltwater flows into the North Atlantic, it's been cooling a specific patch of ocean researchers call the North Atlantic Cold Blob, a persistent region of below-average sea surface temperature sitting south of Greenland, even as the rest of the ocean warms. That unusual temperature contrast, a stubborn cold patch surrounded by warming water, appears to be deflecting the polar jet stream, bending its typical path, and helping park heat domes over the continent in configurations that differ meaningfully from historical patterns. That mechanism connects directly to a broader, well-documented reality about just how disproportionately Europe is warming compared to the rest of the planet. The 2025 European State of the Climate Report, published by the EU's Copernicus Climate Change Service, confirmed the continent's long-term warming rate sits at 0.56 degrees Celsius per decade, pushing Europe to approximately 2.4 degrees Celsius above pre-industrial levels, roughly double the current global average of about 1.4 degrees. Researchers examining this gap have identified it as the product of four interlocking physical mechanisms reinforcing one another rather than a single simple cause. Beyond the jet stream deflection tied to Greenland meltwater, researchers point to Europe's fundamental status as a landmass surrounded by a rapidly changing ocean environment, its position downstream of increasingly disrupted Atlantic weather patterns, and feedback effects from declining snow and ice cover across the continent's own mountain ranges, each factor compounding the others rather than acting in isolation. It's worth understanding why a landmass like Europe ends up bearing a disproportionate share of global warming's impact in the first place, since that context helps explain why these successive heat waves keep breaking records, rather than simply repeating them. Continental landmasses warm faster than oceans because water absorbs and redistributes heat far more efficiently than land does, meaning Europe, densely packed with countries sitting almost entirely on continental terrain rather than surrounded by moderating ocean influence, experiences the raw effects of a warming atmosphere more directly and more rapidly than many other populated regions of the globe. The infrastructure gap facing the newly affected northern regions deserves particular attention because it represents a genuinely underappreciated risk buried within this fifth event's altered footprint. Southern European countries like Spain, Italy, and Greece have spent decades gradually adapting to recurring extreme heat, with considerably higher rates of air conditioning penetration, established heat health warning systems, and cultural practices like adjusted working hours built around managing seasonal extremes. Scandinavia and the Baltic states, by contrast, have historically had little practical need for any of that infrastructure, meaning a population now facing genuinely dangerous heat. For the first time, this summer may be considerably less prepared, both physically and institutionally, to manage it safely compared to residents further south who have already endured 4 previous rounds of extreme heat this year alone. The practical consequences of this fifth heat wave's altered jet stream position are already becoming visible on the ground. Extended range forecasts covering the weeks surrounding this event have consistently flagged an expanding drought across Central and Southern Europe, with soil moisture continuing to decline as the hot, dry pattern persists through mid-August. That drought expansion carries genuine consequences well beyond simple discomfort, threatening agricultural yields, straining already limited water supplies, and elevating wildfire risk across exactly the regions now sitting directly beneath this elongated heat dome's northward and eastward reach. For residents across the newly affected northern region specifically, a few practical adjustments matter considerably given how unfamiliar sustained extreme heat remains for these populations. Checking on elderly neighbors who may lack air conditioning entirely, since it's historically been unnecessary in these climates, represents a genuinely important precaution that residents further south have already built into their routines after 4 previous heat waves this year. Closing blinds and windows during peak daytime heat while ventilating homes during cooler overnight hours, standard practice across southern Europe, may feel unfamiliar to households in Scandinavia and the Baltics, but carries real protective value during exactly this kind of unprecedented northern heat. Exposure. Avoiding strenuous outdoor activity during peak afternoon hours matters just as much in a region unaccustomed to genuine heat risk as it does anywhere further south that's already weathered this summer's earlier extremes. It's also worth situating this fifth event within the broader trajectory of Europe's recent summers, since the pattern of repeated, escalating heat waves didn't begin this year. Europe endured similarly devastating heat in 2022, when researchers linked the extreme conditions directly to climate change and specifically flagged jet stream disruption as a key driver, noting even then that the increase in European heat wave frequency was running 3 to 4 times higher than comparable increases observed across other northern mid-belt latitude regions like the United States. That earlier research effectively predicted exactly the kind of escalating jet stream-driven pattern now playing out again in 2026, lending additional credibility to the idea that this year's fifth heat wave, with its distinctly altered footprint, represents a continuation of an already identified trend rather than some entirely unprecedented anomaly arriving out of nowhere. It's genuinely important to be honest about the limits of current scientific understanding here too, rather than presenting the Greenland meltwater connection as a fully settled, universally agreed explanation. Researchers describe this as an underexplored physical mechanism, one actively being studied rather than a long-established textbook certainty, even as the broader pattern of accelerating European warming itself remains extremely well documented and scientifically uncontroversial. The specific pathway connecting Greenland's melting ice sheet to this particular jet stream deflection represents genuinely active research, the kind of scientific question climatologists are still working to fully map out in detail, even as the observable consequences, in the form of increasingly frequent, increasingly far, reaching heat waves, continue accumulating in real time across the continent. That ongoing research effort matters considerably for how forecasters might eventually predict these shifting heat dome positions further in advance. If the Greenland meltwater connection to jet stream deflection continues holding up under further scientific scrutiny, it could eventually offer forecasters an additional early indicator to watch, tracking changes in that North Atlantic cold blob alongside traditional atmospheric pressure data, potentially providing earlier warning about which specific regions of the continent are most likely to bear the brunt of an approaching heat dome's altered trajectory before the pattern fully locks into place overhead. At the end of the day, the fact that Europe's fifth heat wave of the summer looks meaningfully different from its predecessors isn't simply a matter of degree, more heat piled onto an already brutal season. It reflects a genuine shift in the underlying atmospheric configuration driving these events. A jet stream nudged into a new position by forces as distant and seemingly unrelated as Greenland's melting ice sheet is now delivering extreme heat to populations and regions that had largely been spared through the summer's first 4 waves. A reminder that the mechanisms behind Europe's accelerating warming remain considerably more interconnected and considerably more consequential than any single heat dome story can fully capture on its own. That interconnectedness is likely to remain a defining feature of how Europe's summers continue evolving in the years ahead, rather than a one-time quirk unique to this particular season. As the Greenland ice sheet continues losing mass and that North Atlantic cold blob persists or potentially expands, forecasters and climate researchers alike will be watching closely to see whether jet stream deflections, like the one driving this 5th heat wave, become an increasingly routine feature of European summers, or whether this year's unusual sequence of 5 distinct, geographically shifting heat domes ultimately proves to be an outlier even within an already rapidly warming climate. If you want to keep tracking exactly how this pattern develops, along with the real science behind every European heatwave headline, before it becomes tomorrow's viral clip, subscribe to the channel so you never miss an update. Stay cool, stay informed, and I'll see you in the next one, ready to break down whatever this reshaped jet stream sends across the continent next.